You are welcome to today's class, and today we are studying a very important theorem in circuit analysis called the Thevenin's theorem. Now, Thevenin proposed a very important theorem that has become very useful in circuit analysis. Let's say, for instance, you have a circuit that looks like this, and this time you are just interested in the current in a certain load resistor RL within the circuit. So let's say you have a circuit that has maybe this resistance and voltage, and you are just interested in the current in a certain load resistor RL. You are not interested in the current in this, in the current in this, in the current in this. Then there is no need for the Kirchhoff's law that will lead you to find the current in almost all the resistors. Now, one important thing is that maybe you have a certain circuit and there's an element RL within the circuit, and you want to just check its behavior. For instance, let's say this RL is say 2 ohms. Now, do you know that if this RL is 2 ohms, the amount of current that will pass here, that will pass here, that will pass here will change? Now, if this RL changes to 3 ohms, then it means that the amount of current here, the amount of current here, and the amount of current here will also change again. What if it's 5 ohms? So what it means is that as you vary this or you change this resistance, the amount of current within the circuit keep on changing. So what it means is that if you want to study the behavior of this circuit, then you have to keep on analyzing the circuit. Let's say when the resistor is 2 ohm, you have to analyze the circuit to find the whole current within the circuit. When it's 3 ohm, you analyze the whole circuit again. When it's 5 ohm, you analyze the whole circuit again, because the current distribution changes for every change in the load resistor. That becomes very tedious to do. So Thevenin proposed a nice theorem that, let's say if I want to study the behavior of this particular resistor, then I can represent this entire circuit as a voltage and a resistor. As a voltage and a resistor. And that voltage, we call that the Thevenin's voltage, and the resistance is called the Thevenin's resistance. So let's say, for instance, I want to study the behavior of this RL. So according to the Thevenin's theorem, why don't I just represent the rest of the entire circuit here as a certain voltage in series with a certain resistance? So this is VTH and this is RTH. Then the resistor that I want to study its behavior, I can easily put it here, RL. And I will only analyze this circuit if this RL changes. And that's a very interesting theory. So that I don't need to keep on analyzing the entire circuit anytime the load resistor changes. And this makes Thevenin very important. Let's say, for instance, your room, there's a certain bulb there that when you fix maybe a bulb of 2 ohm, it gets bent. Another time you fix 3 ohm, it gets bent. You fix 5 ohm, it gets bent. So maybe you want to study to find out the current, what that is coming to the fan. You don't want the situation where when you put a 2 ohm bulb, you calculate the entire, you have to analyze the entire building to find the current in the bulb. Then when you change it to a 3 ohm resistor, then you have to analyze the entire building again to find the current in that bulb. What it means is that you will keep on doing a lot of analysis just because you want to study the behavior of that bulb. So Thevenin says that for that particular bulb, just represent the terminal there at where the bulb is. What it means is that first of all, you have to remove the bulb. Then when you remove the bulb, you are going to represent the terminal there as a voltage and a resistor. Then the bulb that you remove, you come and put it in series here. And anytime this load resistor changes, you will not need to analyze the entire circuit here again. Just analyze this simple circuit and find the current in the load resistor. So basically that is Thevenin. Now, practically, if you want to study the Thevenin's idea, what it means is that as we were talking about this circuit as we are drawing, so you want to study this circuit as we have drawn, and you want to find the current in this load resistor because maybe it will keep changing. So Thevenin is just saying that just remove this RL, come and put the RL here. Then what you do is just remove this RL here, like this, and then come and find the voltage at this terminal. Call it VTH. After that, go and find the resistance at this terminal, call it RTH, and put them in series with the load resistor that you removed. And practically, this Thevenin's theorem has been tested and realized that this thing works, right? By just removing the element that you want to analyze, then you measure the voltage at that terminal. Then you also find the resistance at that terminal, and you put it in series, and you can easily analyze this simple circuit like this. So let's go into how we are going to do that. Now, practically, if you are supposed to implement this Thevenin's theorem, it's very simple to implement the Thevenin's theorem. Now, according to the Thevenin's theorem, if you want to find the current in, say, this RL, let's see another circuit, this RL, the first thing to do is to first remove this resistor. Remove the resistor, right? Now, when you remove the resistor, the circuit just becomes like this, like this. Now, as you have removed the element, according to the Thevenin's theorem, come and measure the voltage here. So what means that if you are supposed to do this thing practically, Thevenin's theorem would have been very short. All that he's saying is that the element that you want to find the current or the voltage across it, what you need to do is to first remove the element. Now, when you remove the element, what happens is that go and bring a voltmeter and come and measure the voltage at the terminal A, B. Come and measure that voltage, and that voltage, call it the Thevenin's voltage. The Thevenin's voltage. In the same way, according to Thevenin's theorem, you need to take an ohmmeter, right? Take an ohmmeter to measure the resistance at the terminal AB. So we are basically going to now come to this terminal that we remove the element here. And now we are going to put an ohmmeter here to measure the resistance seen at this terminal. Now, the main issue is if you want to measure the resistance seen at this terminal, that's you want to measure the total resistance of the circuit. If this voltage source remains within the circuit, what happens is that it's going to influence the total resistance that you are going to measure, right? So according to the Thevenin's theorem, before you bring the ohmmeter to measure the resistance seen at that terminal, what you should do is that you have to put all the sources within the circuit off. So it becomes something like this. So we bring the ohmmeter, and because I had the voltage source, I'm going to short the voltage source because that's the only way to remove a voltage source. So I remove the voltage source before I use the ohmmeter to measure the resistance seen at that terminal. And I call that RTH. So practically, we are actually done with Thevenin's theorem. He says that if you want to find the current in anything, remove that thing. After removing that thing, take a voltmeter, measure the voltage at that terminal, like this. When you measure that voltage at that terminal, call it VTH. Afterwards, take an ohmmeter, come and measure the resistance seen at that terminal. But before you measure the resistance, make sure you remove all other sources. Because actually, how does this ohmmeter work? This ohmmeter mostly has a certain voltage. Let's say if it's a 5 volt ohmmeter, what happens is that it actually pushes an amount of current within the circuit so that it can find the resistance as the voltage divided by that current. So what it means is that if you still have your source within the circuit, it's going to influence how much current will flow from the ohmmeter, and the ohmmeter will not be able to give the exact reading of the resistance within the circuit. So that is why you need to remove every other source within the circuit and then before you measure the resistance. So in summary, like your house case, let's say it's a bulb, you are interested in finding the current in that bulb. All that Thevenin is saying is that remove the bulb. After removing the bulb, take a voltmeter, go and measure the voltage at where the bulb was and call that voltage Thevenin's voltage. Afterwards, take an ohmmeter, but make sure that you switch all the lights in the room off Switch everything off. Take all sources away before you put an ohmmeter to measure the resistance, which we call RTH. Now, after getting VTH and RTH, you get something we call the Thevenin's equivalent circuit. And the Thevenin's equivalent circuit basically is the VTH you measured in series with the RTH you measured. Then you can now bring the load resistor you removed here and analyze this simple circuit. What it means is that if this load resistor becomes 2, I analyze this simple circuit. If it becomes 3, I analyze this simple circuit. If it becomes 5, I analyze this simple circuit, and I'll easily get the answer instead of coming back to the main problem and finding the current in this load resistor anytime the load changes. So basically, this is just the concept of the Thevenin's theorem. Remove the element, take a voltmeter, measure the voltage. After that, take an ohmmeter, measure the, but before you measure the resistance, you need to remove all the sources. And after removing all the sources, then you can measure the resistance. Then you can now draw the Thevenin's equivalent circuit. That means the voltage you measured and the resistance you measured, you put them in series there, and the element or the load resistor you remove, come and fix it at the equivalent circuit terminal, and you'll be able to analyze the circuit. This is the basic concept of the Thevenin's theory. But now, this time, we are going to use our hand to rather calculate the voltage instead of measuring the voltage. So we are just going to use our hand to calculate the voltage. Then we are going to use our hand to calculate the resistance. Now, how are we going to do that? We are just going to use the basic idea that we are going to remove the element, measure the voltage. After that, we will remove all sources and measure the resistance. So now, how do we find VTH according to Thevenin? If I had a voltmeter, I would have just measured. But because we are going to use our hand, what we are going to do is that number one, we are first going to remove the elements. Anytime we want to find the current in anything, we'll first remove. We'll first remove, then after that, we will find the VTH. Now, how am I going to find the RTH? What I'm going to do is that, number one, I'll remove the element. Then when I remove the element, I will find the total resistance. But don't forget that before I find this total resistance, I should note that I will remove all sources. I will remove all sources. So this brings us to the end of the basic concept behind the Thevenin's theorem. Measure the voltage, measure the resistance, but before you measure the resistance, remove all sources, and after that you find the total resistance. So the part 1 of this Thevenin's theorem ends here. In part 2, we are going to see how practically we are going to use our hand to calculate this Thevenin's voltage and this Thevenin resistance instead of measuring them. Thank you very much.